Hello and welcome back. And in this video, we are going to see a practical example and its code for using the polynomial regression. This is an example where the polynomial regression has been used. So let's say we want to predict the house price based on the features like square footage, number of bedrooms, and the age of the house. You know that whenever you buy some property, some kind of flat, something like that. So in that case, it all depends. Like there are different features like number of bedrooms, number of bathrooms, right, and the other things like what is the square feet area and what is the age of the house. So everything matters, right? So a simple linear regression model might not capture complex relationship. What does this mean? This means that suppose you have predicted something like you can see some kind of pattern, like when there are two bedrooms, then the price is like something uh, 12 lakhs or 12 million, something like that. And when you go with the uh, four bedrooms, then it becomes 24 million, right? Something like that. So you are able to see some kind of linear, a kind of relation. If you are increasing the number of bedrooms, then there is a linear relationship, which means like every time the price will become twice, right? If earlier there were two bedrooms, then the price was 12 millions, but now if there are four bedrooms, then it becomes like 24 million. But in the real life, it doesn't happen. If you are going with the only with the bedrooms, then also it may not be every time fitted because it all depends on the various factors like where do you live, what is the area where you are taking this property, where you are purchasing this property. So all these things matter, right? So if the number of features increases, like earlier it was only the number of square feet or the number of bedrooms, but now if it increases, like what is the locality, right? Number of washrooms and the number of balconies, the carpet area. So all these things, when they are combined together, then it becomes really complex to correctly predict the things, right? So in that case, we need to use the polynomial regression because linear regression cannot capture the complex relationship, right? In case of such kind of problems where number of features are involved. So, because in that case, it may be that the diminishing returns for additional square footage may be there. Like if you are increasing even 2 to 3 square feet, then also the price is not increasing. It may be that if you are increasing till 20 square feet, then in that case also there is no price is increasing, right? It may be that even with a single square feet, the price is increasing very high, right? So those kind of scenarios will be there, right, in the real life. That is why we cannot go with the simple linear regression model where there is a linear relationship. Linear relationship, this is the simple equation, right? Y is equal to m into x plus c. This is the simple, regression formula. So the a and b always will be constant. But the thing is that in real life, this a and b, which are this is the gradient a, and this is the intercept on the y-axis, right? This is y is equal to mx plus c. You can see y is equal to mx plus c is there, right? So if you know m is the gradient, right? And the this c, or you can compare this with the b here. So this b is nothing but the intercept on the y-axis. So every time you can predict it easily. But in case of these real world scenarios, you will not be able to predict the things easily. So what happens? It happens that you go with the polynomial regression. So by adding polynomial features, we can model more complex relationships. So what happens that you already have some features like what is the square footage, what is the number of bedroom, and what is the age of the house. These are the variables which are already there. But what you do, you are going to add few new features, right? And those features will be polynomial features. And how you will make the polynomial features? Polynomial means more than degree one, right? So you can see that number of bedrooms. This is it's a single, simple linear, feature. But yeah, if you multiply the number of bedrooms and the age of the house, right? Then in that case, it becomes like this is one, and this is the other feature. And if you multiply them, then obviously the degree becomes two, right? So you are creating, with more than degree one, the feature you are creating with more than degree one, right? Maybe you are going to make the bedroom as a square, right? A square of the bedroom. So all these values or all these features will be new features that you will be adding in your data set, right? Squaring the bedroom size, squaring the age of the house size. So with this, you will be able to see more values, more features, and why we are making their square and cube, all those things that we have already discussed in the previous video, right? So if you have not seen that, I will request that you please go there and first see the previous video, part number 23 of the feature engineering. So here, what we are going to do, we are going to see the how the polynomial regression code is going to help us to decide the price of a property, right? So first of all, you need to import these things. So I'm going to import these, packages, libraries. So sklearn and pandas we are basically using. So first of all, let's see if it is running. Yeah, this is a mistake. Import one, it should be import. So let me run it. It's fine now. Let me correct it here as well. Not import one, it should be import. Okay, now we are preparing the sample data. So here the sample data is really small, right? I'm taking only the 5 data points here. Five rows are here. Square feet is 1,000. Then if the number of bedrooms are two, and if the age is 5 years, then this is 1 lakh, right? This is the price. And similarly, the other records. If the square feet area is 1,500 and the number of bedrooms are three, the age is 10 years, then in that case, 1,50,000 will be the price, right? So these are the sample data which are with us, right? So this is the sample data. Let us see if it is fine. Yes, it is fine. Now let's come to the framing the data and doing the feature engineering. Okay, so what I'm going to do, I'm simply going to, framing the data. I'm loading the data into the data frame, and I'm passing this data, which is basically a kind of a dictionary. So I'm passing it here, and I'm doing the feature engineering here. So we are creating polynomial features. So I'm creating the polynomial features of degree 2, right? So square feet, bedroom, age, right? So all these features, they will be, multiplied or will be squared up to create more new features, and there will be new columns in the data set, right? Just like square feet, bedroom, age, and price. All these columns are already there. There will be few more columns like price square, maybe the bedroom square, maybe the soft, square feet square, right? So there will be new features. You will be creating another column with the square feet square, and there the values like this is 1,000, so 1,000 into 1,000. That will be the new value in that particular column, right? So based on the kind of representation of the data, you just do that. So when you will need this degree 2, that you can decide based on the plotting of the graph. You can plot the graph against these data points, like how they look like. Okay. And based on that, you can decide. So here I'm already aware that yes, there is a degree 2 thing. So I'm just adding it. In the next video, I will show you that how you can plot it. In fact, I have already told you that how you can plot your data using the various libraries in Python, right? So that library can help you to draw the graph, draw the chart, in fact, right? So here we are going to do the fit transform. So what we are going to do fit transform here, we are training our model, right? Fit transform is square feet, bedroom, and age, because these are the independent variables and the price is the dependent variable. We have to know this thing. We have to find this thing, right? So these are the independent variables. So when we are fitting the values, what do you mean by fitting? Fitting means finding out the value of if you have some kind of equation like here we have the example. If you have this kind of like square ax square plus bx plus c, right? You can consider this as x. So ax square plus bx plus c, if you have something like that, then in that case you have to find out the value of a, b, and c, right? Because these are the variables which decides that what will be the slope of a slope of a curve, right? Slope of a line, right? So basically the slope of a curve, what will be the value of a, b, and c, the intercept on the y-axis, what will be this value. This decides like how the actual line or how the actual curve will look like, which can be used for predicting the real values, right? So fit transform does the same thing. It does a number of it tests it number of times, it do the regression. This is known as the regression, and finally it knows that yes, now I'm able to get the best of the results which are most accurate when compared to the real values. Then in that case it stops there and it gives you the value of a, b, and c, and based on that your model will be prepared, your accurate model will be prepared. And then this is the y, which is df price. So x and y both have been taken, and now I'm going to train it. Okay, so let me do this. So I'm splitting the data into training and um, test set. So let us see what does this mean. So I'm going to add here. Yeah, this is fine. So now I'm splitting the data into training and test set. So you can see the test size is 0.2, which means that whatever data I have used here, whatever data I'm using for training here, not all data I will use for training. Basically, some part of data I will use for training and rest of the part I will leave, so that I will be using that rest of the data as a real world input, considering that as a real world input, and then I will test that real world input against the trained model so that we can see if we are able to see what is the output which is just very close, just very close, or what is the just very close, or you can say like how it is performing. Is it close or is it not close to that data, right? To the real value, right? So here, if you say like its test size is equal to 0.2, which means that 20% of the records will be used for the testing, right? So there will be only four records. There are five records, so there will be only four records which will be used for training the model. But one record will be there which will be used for finding out the actual results. To not finding out the actual result, basically to compare the actual result versus the predicted result, which has been taken from your model, right? Your model will be predicting some value based on the real data. You will suppose you are taking these four things, like these four records where the square feet is 1500, 2000, and this 2500 and 3000. You are taking this data as the training data, and you are taking this 1000 square feet as the your real data for testing, because you have left it. 0.2 means 20% data you are leaving for the testing. So in that case, if the value is coming very close to this price, 1 lakh, then in that case, we will see that yes, we will be able to understand that yes, this model is really helpful, right? So, and this model is really predicting the correct value. So if you see here, if you pass like X, which is the independent variable set, and if you pass the y, which is the dependent variable set, and then if you give test size, then it returns you four values. One is training set x underscore train, x underscore test, then y underscore train, and y underscore test. So these four values are returned, right? If you print them, print x underscore train, then how does it look like? Let us see. So it looks like something like this. So training set is looking like this. So you can find out like what has been taken in the training set. So in the training set, we have taken square feet is 1000, 1500, right? So this is 1500, and then there is 2000, right? So this is the 2000, square feet is 2000. So we need to see, because here it is not giving you the exact value. So let me just print like x underscore train. If I print it, then let's see what comes. So this is coming the same. Okay, let me print the x underscore test so that I can find out what it is using for testing, right? That I have to find x underscore test. That's why I'm doing the exercise. So here it is like, okay, this is 5.001, 2.05, 2.50. So it looks like this is the one, 2500. This is the one which it is using, right? So this is the array of test values. So 1.00, 2.5. So everywhere this 1.00 is already there. So this might have been created using the because there are three features, right? So now more features will be created of degree 2 to make it degree 2. That is why you are able to see number of not only one, two, three, four features, rather you are able to see five, six, seven, eight, nine, 10 features, in fact, right? So which one is the square and which one is the real one, that we need to check. So if you see 2.5, this is not mentioned anywhere. So how we will find it out? Okay, 6.25, something like here we are able to see 6.25. We are not able to see that one. So we need to check how we can see this value as the real values. Okay, so y underscore test. Let me print y underscore test so that I can identify. So let me see. So 2,50,000. Okay. Y underscore test is an independent variable. That's why it is giving like this. But yeah, here it's like converting it into some value, exponential value. That's why it is not giving the correct value so that I can identify 149. Let me see. 1.69, 1.6 means 4 4s are 16, 3 means 9. First one is, this is the one, 2, and then third one, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 features, okay. So we are not able to get this, like what is the training data and what is the test data. So anyways, I will show you that how you can find it out in the next video because somehow I'm missing few things here. So let me move ahead and let me just print this thing, create and train the model. Now you are actually, creating and training the model. So here you are using the fit method. So there is a difference between the fit and the fit transform method that I have explained earlier in this series so that you can refer from the previous videos. So fit method here it is going to actually train on the X and train models to find out the relationship. But here if you see fit transform, it was just to find out a natural relationship between these independent variables. But here, based on the training values, based on the output, you are going to find out the relationship, right? So fit will do that thing, right? So that way, fit is working on the real values, the predicted values, and the set of independent variables. But there, it was only the independent variables based on which it was trying to find out some relationship. Now, here we are going to use this, make predictions on the test set. Let us see how it is able to predict it. Let me run it. Me, yeah, y underscore predict. So x underscore test. But the problem is that we don't know that what is actually that value where the x test has been used. Hopefully this 6.25 is there. So 25, uh, the square of 25 is 6 point, it's like 625. So it seems like something related to this only, where the square root value is 25. Sorry, the square is 625. This can be only possible for this, right? So let us see how close it is if it is using that predicted model. So prediction model. So how it is giving me the result. Code predict. Let me run it. So you can see 2, 4, 4 times 9, right? So it seems like it is using this one 25 only. So 2, 4, 4 times 9, or maybe this one it is using as a test one, 2500 and then 4 and then 20. So something around the X test, which is looking like the data, right? So I will tell you in the next video that how you will identify that what was the test data. So here it should have used it has used since we have used the very small data set. So here we are very much sure that what will be the output. And in the next video, we will see that how you can find it out.